How much does it cost to operate a submersible pump? As a professional water systems contractor, at some point you're going to get asked, how much does it cost to operate a well with a submersible pump? In this short video, we're going to explore that topic and show you how to calculate the monthly cost to operate a submersible pump and motor. Actually, this works for any electrical device once we know three things. Those three things are the power consumption of our device in kilowatts, how many hours per month our device is going to operate, and how much our electricity cost per kilowatt hour will be. Our monthly cost comes from multiplying these three items together. That is, the power consumption of the device multiplied by the number of hours per month the device operates, multiplied by the cost per kilowatt hour. We start with looking up the power consumption of the motor, which should be supplied by the motor manufacturer. For Franklin submersibles, use the Franklin Electric Application Installation and Maintenance Manual, otherwise known as the AIM Manual. The power ratings for the motors are listed on page 13 for single phase, or pages 22 through 28 for three-phase. Let's do a quick example. We'll use a half-horse single-phase motor which at maximum load consumes 960 watts, which when divided by 1,000 will convert to 0.96 kilowatts. The wattage rating of a motor is dependent on the horsepower rating of the motor, not the voltage. So regardless of the voltage rating of the motor, the wattage for that horsepower will be the same. Figuring out the number of hours per month the pump and motor are going to operate is a little trickier. In the U.S., the average water consumption per person per day is 120 gallons. If we also go with an average of 4 people per household, we will multiply 4 times 120, which gives us 480 gallons per household per day. To keep things simple, let's say we've got a 10-gallon per minute pump down the hole. If we take our 480 gallons per day and divide by the pumping rate of 10 gallons per minute, we will have a run time of 48 minutes. If we take 30 days times 48 minutes, we will have a total of 24 hours of operation. So far, we have a pump-motor combination running 24 hours per month and consuming 0.96 kilowatts per hour. The last thing we need to know is how much we are paying for that power. In the United States, the cost of electric power varies widely, but we pay an average of around 12 cents per kilowatt hour. A kilowatt hour is 1 kilowatt of electricity consumption for 1 hour. In the case of our half-horse submersible motor example, the kilowatt hours per month would be 0.96 kilowatts times 24 hours, or 23 kilowatt hours total. So our submersible pump and motor is using 23 kilowatt hours of electricity per month and going with the average of 12 cents per kilowatt hour. All that's left to do is multiply 23 kilowatt hours by 12 cents. That gives us $2.76. So that's the cost per month to operate a 1/2 horse Franklin Electric submersible motor for an average residence in the United States. Pretty good deal. Just to take this one step further, let's say our submersible pump above runs 24/7, perhaps a fountain application. Our motor still consumes 0.96 kilowatts, but now it operates 24 hours per day over the course of 30 days, for a total of 720 hours. Multiplying 0.96 kilowatts by 720 hours gives us 691 kilowatt hours per month. If we're still paying 12 cents per kilowatt hour, then our monthly cost is $82.94 per month. That's moving a lot of water for not a lot of expense. Once again, it shows what a great deal a private water system offers to the homeowner, the farmer, or the business.